electronic structure. Now, as we discussed in the previous lecture, that atom is made up of protons, neutrons, and electrons. The central part of the atom is the nucleus, and electrons are revolving around the nucleus uh, in in a specific region, giving it a particular energy. So, electrons that surround a nucleus are confined to regions called the principal energy levels or shells. These shells are numbered. These shells here are numbered n equals to 1, 2, 3, 4, and so forth. This one, the shell that's closer to the nucleus, is n equals to 1, 2, 3, 4, and so on. Electrons closer to the nucleus, or the electrons, the ones which will be in this shell, they are closer to the nucleus, are held more tightly and are lower in energy. On the other hand, electrons farther from the nucleus are held less tightly and are higher in energy. So, and also the farther a shell is from the nucleus, the larger is its volume, and because so it can hold more electrons. Now these shells, for example, n equals to 1, n equals to 2, these are the shells. These shells are further divided into subshells, which are denoted by the letters SPDF. These subshells consist of orbitals. And what is an orbital? It's a region of space where there is a maximum probability of finding the electron. Now, a particular type of subshell contains a specific number of orbitals. For example, S subshell contains only one s orbital, we call it S, and p subshell has 3 p orbitals, d subshell has 5 d orbitals, and f subshell has 2, 3, 4, 5, 7 orbitals, and each orbital can hold maximum 2 electrons. That means we can say that means in S subshell we can have only 2 electrons. In P subshell, which is made up of 3 p orbitals, and each orbital, since it can hold 2 electrons, so p orbital can have maximum 6 electrons, d can have 10, and f 14. So these are the ways electrons are filled in the different energy levels. So here the next thing we're going to learn is how to write the electronic configuration. So the first rule is to write a complete electronic configuration for an uncharged atom. Find the number of electrons in the atom from its atomic number. Let's say we want to write down the electronic configuration of carbon. This carbon 6, the 6 is the atomic number. Atomic number is the number of protons, means it has 6 protons. For a neutral atom, number of protons are always equal to number of electrons, which is 6. So now we know an atom of carbon has 6 electrons. Then how are we going to write down the configuration? Then we add electrons to the sublevels in the correct order of filling. Remember, 2 electrons to each S sublevel, 6 to each P, 10 to D, and 14 to F. And we start here. So how many electrons we have? 6, and we want to find out how these 6 atoms are arranged around the nucleus. The first one is 1s. What does 1s mean? Means the first energy level and the S sublevel. And how many electrons we can put in S2? So 1s2. Then you follow the second line. What is written there? 2s. Means now we are in the second energy level, but still in the S sublevel. And again, how many electrons can be put in the S2? After that, you're going to fill the 2p orbital, 2p sublevel. And how many maximum electrons you can put in p? You can put maximum 6. But here's the thing, we are writing the electronic configuration of carbon, which has total 6 electrons. We are already done putting 2 in this one, 2 in this one. Then how many are left? 2. So the electronic configuration of carbon is 1s2, 2s2, 2p2. Means here in the nucleus, in the first energy level, which is this, you have 2 electrons. In the second energy level, which is subdivided into S and P, there are 2 in S and 2 in P. Now let's take more examples here. For example, let's write down the electronic configuration of sodium, which is sodium is atomic number is 11, means 11 protons, means 11 electrons. So we're going to start with the first one here, 1s, 2 electrons. Then look at the second line, has 2s2. Then follow the third line, 2p. So 2 plus 2, 4. P can have maximum 6. And what is after 2p? 3s. How many maximum electrons can go in S? 2. But how many we need? 2, 4, 6. We need only 1. So 2 plus 2, 4 plus 6, 10 and 1, 11. So this is the electronic configuration of sodium. So here, the first energy level, this has 2 electrons. Second energy level, this is a second energy level. There are total 8 electrons in this, 2 in 2s and 6 in 2p. And the third energy level has 1 electron. The electronic configuration gives you a lot of information. For example, how many electrons are present in the outermost shell? 1. That means this element is in the 1a group. The electrons present in the outermost shell are denoted by the group number. Also, how many total shells are in this sodium? 3 shells. First shell, second shell and third shell. The number of shells means the row. This element is in the third row and in the first A group. Not only that, we can also write down the noble gas configuration of these elements. Noble gas configuration means it is the shorthand way of writing the electronic configurations. And what we do, for example, again, sodium 11, its electronic configuration is 1s2, 2s2, 2p6, 3s1. This 1s2, 2s2, 2p6, instead of writing this, we can write down neon 3s1. Where does this neon come from? Neon is a noble gas. The eighth A group, all the noble gases are helium, neon, argon, krypton, xenon, and radon. Now neon has 10 electrons. Its atomic number is 10. So the first, instead of writing the first 10 electrons, we are writing neon. Because what we care about is how many electrons are present in the outermost shell. Because electronic configuration basically helps us to explain the chemical properties of an element, and all the properties can be explained just by looking at the electrons present in the outermost shell. So this is the noble gas abbreviation of sodium. Let's take one more example. For example, let's take the example of calcium. Now calcium atomic number is 20. If you look in the periodic table, its atomic number is 20. 20 atomic number means 20 electrons. So here is calcium 20. How are we going to write down its electronic configuration? Starting from here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now here, instead of, so these up till here are 18 electrons. These are 18 plus 220. For 18, instead of writing 18, so you can write down argon. Again, argon is a noble gas. It has 18 electrons because its atomic number is 18. So all you have to do is to write down argon 4s2. Again, look at the outermost shell. Outermost shell is 4. How many electrons are in the outermost shell? 2. Means this element is in the second group. It's in the 2a group. Also, this was the outermost shell, 4th. 4th shell means this element is in the 4th row. 4th row, second column. And argon 4s2 is the shorthand or the noble gas configuration of calcium 20.
Made with Doodlecast Pro.